To find a derivative using the product, chain, or quotient rule. Sometimes it's a combination of all three, or any two. Here's an example. Just for the product rule, let's say we have y equals 3x squared plus 4x, and then multiply that by 2x to the third minus 5x squared. For the product rule, you have to alternate the process. So what I do most of the time is I start with what's given first, 3x squared plus 4x, and then multiply that by the derivative of the second, 2x to the third minus 5x squared. Then add to that and reverse the process. You need 2x to the third here minus 5x squared, and then times the derivative of 3x squared plus 4x. And I have to squeeze that in there. Alright, so let's go back and simplify. We'll have 3x squared plus 4x staying the same, but then the derivative of the next term here is 6x squared minus 10x. Now the first quantity in the next set stays the same, 2x cubed minus 5x squared. Now you need the derivative of this term, 6x plus 4. I put an extra parenthesis in there. I stopped halfway through it. Now you have to use FOIL, multiply out. So we're multiplying these two quantities here to come up with 18x to the fourth minus 30x to the third plus 24x to the third minus 40x squared. And then multiply the back two quantities. We're going to have to skip down to another line eventually. Since you have a plus sign here, there's no need to put a set of parentheses still. So we'll have 12x to the fourth plus 8x to the third, and then down to the next line, minus 30x to the third minus 20x squared. So now we have to go back and simplify like terms. The highest power in here is a fourth, so let's go ahead and knock those out first. 18x to the fourth, 12x to the fourth is going to be 30x to the fourth. So those are now gone. And we'll color them in once we're finished with them. So now we have the thirds to take care of. This is a minus 30, and plus 24 is going to be a negative 6. Negative 6 plus 8 is a positive 2. Positive 2 minus 30 should be minus 28, x to the third. And then what's left are going to be the squares. You have, is that a minus 40x squared? Minus 40x squared, and then minus 20x squared is going to be minus 60x squared. Try this one and drop it off up here at the desk. For your solution here, you're going to start with 2x to the fourth minus 3x, at least I am, and then multiply it by the derivative of 4x squared minus x. And now add to that the reverse of the process. We'll have 4x squared minus x, and then times the derivative of 2x to the fourth minus 3x. Alright, so 2x to the fourth minus 3x stays the same, and then 8x minus 1 is the derivative of this term, and then we need 4x squared minus x to stay the same, and now the derivative of this term is 8x to the third minus 3. So now we have to multiply. Multiply these two together to get 16x to the 5th minus 2x to the 4th. And then we'll have minus 20x squared plus 3x. This is a plus sign, so there's no need to keep parentheses. 32x to the 5th minus 12x squared, and we'll go to the next line, minus 8x to the 4th, and then plus 3x. Now we have to simplify. We'll start with the x to the 5th first, so you have a 16 and a 32. That would be 48. X to the 5th. Now we'll go to the 4ths, and we have, is that a plus or a minus right here? That's a minus 2x to the 4th, and minus 8x to the 4th is minus 10x to the 4th. So now we have minus 24x squared minus 12x squared is minus 36x squared. And then what's left over is a 3x and a 3x, which would be 6x. This will be an example of the chain rule, and the problem is the square root of 4x to the 3rd plus 5x squared. We want the derivative of that. So to find that, we need the derivative of the item under the radical sign, which is 4x to the 3rd plus 5x squared. And all of that over 2 times the radical quantity, square root of 4x to the 3rd plus 5x squared. On the top, the denominator, or not the denominator, but the derivative is going to be 12x squared plus 10x. And then on the bottom, we will stay with 2 times the square root of 4x to the 3rd plus 5x squared. Now we must simplify. We cannot have the radical item on the bottom, so we multiply the top and the bottom by that item. Square root of 4x to the 3rd plus 5x squared over top itself. And when you do that, on the top you're left with the quantity 12x squared plus 10x times the square root of 4x to the 3rd plus 5x squared. And on the bottom, when you multiply the 2 radical quantities together, the square root sign is gone and you're just left with 1 of that item. So in your mind, think of this being by itself now, and you have to multiply it by 2. So that would give you 8x to the 3rd plus 10x squared. We're going to find the derivative here, and to start off with, we need the derivative of the quantity under the radical sign, 6x squared. And then on the bottom, we need 2 times that radical quantity. The derivative from the top is going to be 12x, and on the bottom you still have 2 times the square root of 6x squared. You must multiply the top and the bottom by the square root of 6x squared so that we can simplify this to 12x square root of 6x squared over 12x squared. Now we're not finished by a long shot, because notice here the 12s are gone, and as well as an x on top and an x from the bottom. So we have an x on the bottom, and on the top we still have the square root of 6x squared. We're not finished yet. Notice that we have x squared underneath the radical sign. So you have square root of 6 times the square root of x squared, and that is x square root of 6 over x, which can be simplified all the way down to square root of 6. This is another practice problem, It is y equals the square root of 25x to the fourth. Find the derivative. The solution for this is that the square root of 25x to the fourth simplifies to 5x squared, and the derivative is 10x.